In this problem, we got the following. We got an object that is launched from x0 equals 0, initial y equals 100, with v of x equal 50 ms and v of y 50 meters per second. In the presence of acceleration, a equals negative 10 meters per second squared. The first question says, find the initial vector velocity and the angle it makes with the positive y-axis. So, this is what I drew. The y direction and the x direction, both being equal to 50 meters per second. And right here, we have the connection of the triangle, and we have the angle theta. Now to find the angle theta, we have to do the inverse of tangent, and in parentheses, we divide 50 by 50. That should give us 1. So to find the angle, we just plug it into the calculator, and that should give us an angle of 45 degrees. Now, in regards with the initial vector velocity, connect to the following. Magnitude of b equals to square root of 50 squared plus 50 squared, and that should give us 70.7 meters per second. In letter b, they're asking us to rewrite the equations for x of t and y of t. For x of t, we're going to find the initial value for x plus the initial velocity in regards to x times time. In the y direction, y of t, going to initial y plus initial velocity of y by time plus 1/2 times acceleration by time squared, which is in this case accounting for the gravity. In letter C, they're asking us to rewrite, or in this case write equations for Vx and Vy, referring to the velocity. So that should be the following. For v of x, we have the initial velocity of x, that's just the 50 meters squared. For b of y, it's going to be the same thing, but in this case, we're going to add the effect of gravity over time. In this case, acceleration by time squared. Letter D, you have to find the time to hit the floor and to find the range. So we drew a little representation, and this time is going to be in seconds. X is going to be the distance in meters. So we're going to use the following equation. Y of t being equal initial y plus initial velocity of y by time plus 1/2 acceleration by time squared. And we're going to set it equal to 0 so we can find what's the time it takes to hit the floor. So we know that y0 is going to be 100. The initial velocity of y is going to be 50 by time, which we don't know yet, and we're trying to solve for. Plus 1/2 negative 10 for the acceleration given by time squared equal to 0. So as we continue doing the algebra, we can also multiply both sides by -1. So we could have a formula positive. In this case, we're trying to solve for t using the quadratic formula, and we're going to get two values, 9.4 and 4.3. Now there was a problem with the values given, as I noticed. So in this case, we're going to use the bigger option, because in this case, it was supposed to be negative. Next, to find the range, we're going to use r equals initial velocity of x by time. It's going to be 50 by the value that we chose using the quadratic formula, 9.4. That should give us 470 meters. So letter E says write the equation for the trajectory of the object. In this case, it's going to be y of x, but now we only have y of t, which is the following. So we're going to use xt, the value that we have at first, x0 plus v of xt which is 0 plus 50t, or just 50t. So as we solve for t, we're going to have a value of x over 50 minus 0, or just x minus 50. So now we can find y of x. So wherever you see the t, we're going to plug in this value into the equation that we use for the quadratic formula. So as we simplify this in the following steps, we get y of x equals 1 over 500 x squared plus x plus 100. So now we're going to use the quadratic formula again to find the coordinates of y of x. So in this case, we get two values, negative 138.19 and negative 360. Now again, since the values given were wrong, we should have gotten a positive answer and one negative answer, and we would have chosen the positive answer. So in the graph, we should have gotten something like this. We should have gotten a big number such as 360 and negative answer. In this case, we're just gonna call it the negative 138. So next question F, at what time does the object reach its maximum height? So in this graph, the maximum height would be somewhere in the middle of this graph that I just drew. So this is the height, and we're trying to find its maximum height in meters. So for that, we have to set up v of y equals 0. That means that at the maximum height, there's no velocity at all. So that's equal to 0. Now with that said, we're gonna use the equation Vy equals initial velocity y plus acceleration by time. And we just put in the values 50 plus minus 10 by time equals 0. So we get 50 minus 10t. We move the 50 to the left. We have two negative signs that we can cancel out. 50 over 10, that should be 5 seconds for the time. So that's the amount of time that it takes to reach the maximum height. So next, to find the meters, because it says in the question, find the time in meters. So we're going to use this equation, y of t equals y0 plus initial velocity y times time plus 1/2 at squared. So we're going to do y of 5 seconds. That's going to be 100 plus 50 plus 5 plus 1/2 times negative 10 times 5 squared. And that should give us 225 meters.